So in this video we're going to determine the equation of a line that is perpendicular to a given line instead of parallel, and that passes through a given point. So for this example it says consider the line given by 2x plus 5y equals 4. Determine or find the equation of the line that is perpendicular to this line and that passes through or contains the point 3, 5. So what we want to remember is that for two lines to be perpendicular, their slopes must be negative reciprocals. They move in opposite ways through space, which is why their slopes are negative reciprocals. So step one is to recognize that to determine the equation of any line that exists that is perpendicular to this line, we first need to know what the slope of this line is. So we start with the line to which we want to be perpendicular, 2x plus 5y equals 4, and then we put it into the y equals mx plus b form, the slope-intercept form, so we can figure out what the slope is. So I'm going to start by subtracting 2x from both sides, which will leave me with 5y on the left-hand side, and negative 2x, or subtract 2x, plus 4 on the right-hand side. Plus 4 because this was a positive 4, so it's being added on the right-hand side. And then I'm going to divide everything on both sides by 5. 5 divided by 5 is 1y, which equals negative 2/5 x plus 4/5. And notice that I have this is the same line that I started with. It was in standard form to begin with. Now it's just in slope-intercept form. I don't really care what its y-intercept is, but I do care what his slope is, and he is in the mx plus b form, so I know his slope is equal to negative 2/5. I know every line that is perpendicular to this line has a slope that is the negative reciprocal of that. So to come up with my perpendicular line at the point 3/5, or that contains the point 3/5, I need to calculate the slope of the perpendicular line. But the slope of the perpendicular line is going to equal the negative reciprocal of the other line's slope. So the negative reciprocal of this line, the reciprocal of this slope, the reciprocal of negative 2/5 is negative 5/2. So the negative reciprocal is going to be positive 5/2 because I get a double negation right here. So every line that is perpendicular to this line right here will have this slope. So now I know that the equation of a line can be given by the slope-intercept form by doing 5/2 of x plus b. I know the slope has to be 5/2, and then I can take this point and I can plug in y equal 5, or output is 5, corresponds to input of 3, so I can replace the output f of x with 5. But if I do that, I need to replace the input variable with the 3, the number that generates the output of 5, and it's plus b. So this is going to be 5 minus, I'm going to subtract 5/2 times 3 from both sides, but this is just 5 times 3 is 15/2, so I'm subtracting 15/2 from both sides, which equals b. And I would need to multiply this by 2/2 to get a common denominator, so I'm going to have 2 times 5 is 10, and 10 minus 15 is negative 5/2 is b. So now I can update my equation right here and say, hey, f of x equals 5/2 of an x minus 5/2. So yes, it is the case that we don't necessarily need to use slope-intercept form. There are other forms like the point-slope form, but we haven't done those yet. And kind of for right now, I'm wanting people to really exercise with the slope-intercept form of the line, and then we may do something with the point-slope form later on.